Next we will do a question on second order system. Okay, so a second order real system has the following properties. The first one is that the damping ratio zeta is equal to 0.5 and undamped natural frequency omega n is 10 radians per second. Okay, and the second property is that the steady state value of the output to a unit step input is 1.02. Okay, and we have to find out the transfer function of the system. Okay, so what is the information given? Firstly, we have the damping ratio is 0.5. Okay, and the natural frequency is 10 radians per second. Okay, from this we can find out the characteristic equation, right? So the characteristic equation, we know it is given by s square plus 2 zeta omega ns plus omega n square is equal to 0. Okay, so s square plus 2 into 0.5, zeta is 0.5, into omega is 10, omega n is 10, into s plus omega n square will be 10 square, which is 100. Okay, so this is equal to 0. So we have s square plus 10s plus 100 is equal to 0. So this is the characteristic equation. Okay, so what will be the numerator of the denominator of the transfer function? It will be s square plus 10s plus 100. So the transfer function denominator you can write as s square plus 10s plus 100. Okay, so now we have to find out the numerator. Okay, now the numerator we will take as some constant k. Okay, now how to find the numerator? We have to find from the second point, that is the steady state value of the output. Okay, so it is given that the input is a unit step input, so we will take r of s is equal to 1 by s. Okay, then what is the steady state value of the output? It is 1.02. that means limit t tends to infinity, if output is denoted by c of t, okay, then limit t tends to infinity, c of t is equal to 1.02. Okay, but by final value theorem you can write this as limit s tends to 0, s into c of s is equal to 1.02. Okay, now the output will be transfer function into the input. So here we can write 1.02 is equal to limit s tends to 0, s into r of s into transfer function. Okay, so this you can write as limit s tends to 0, s into 1 by s into k by s square plus 10s plus 100. Okay, so if you substitute s is equal to 0 in this function, then you will get k by 100. Okay, so this is equal to 1.02. This means that k is equal to 102. Okay, so we got the transfer function to be 102 divided by s square plus 10s plus 100. Okay, so this is option B. Next question, we have a second order control system is defined by the following differential equation. Okay, so now we have to find out the damping ratio and natural frequency. Damping ratio is zeta and natural frequency is omega n. Okay, so what is the first thing that we have to do? We have to find out the transfer function, so that the denominator of the transfer function will lead us to the characteristic equation. Okay, so from the characteristic equation you can find out the damping ratio and natural frequency. Okay, so transfer function we will get from this differential equation. Okay, so here c of t is we will take as the output, okay, and u of t as the input. Okay, because this is the general notation. Okay, now if you apply Laplace transform to this differential equation, then you will get 4 into s square c of s plus 8s into C of S plus 16 C of S is equal to 16 U of S. Okay. Now if you take C of S on one side, then you will get 4S square plus 8S plus 16 is equal to 16 U of S. Okay. So now the output C of S divided by the input U of S is equal to 16 by 4S square plus 8S plus 16. Or you can write this as 4 by S square plus 2S plus 4. Okay. So C of S, that is output by input, the ratio of output to input is nothing but the transfer function. Okay. So the denominator of the transfer function is S square plus 2S plus 4. Okay. So if you compare with the standard second order equation, that is S square plus 2 zeta omega ns plus omega n square. Okay. So you can see that 4 is equal to omega n square. So omega n will be equal to 2. Okay. And 2 zeta omega n should be equal to 2. So 2 zeta omega n is equal to 2. Omega n is given to be 2. So zeta we will get as 0.5. Okay. So zeta is 0.5, that is the damping ratio is 0.5 and the natural frequency is 2. Okay. So the answer is 0.5 and 2 radians per second. It is option B.